I want to start with a little bit of history of the internet, if you'll indulge me. So Vannevar Bush, in 1945, wrote a famous article in Atlantic Monthly magazine. It was called As We May Think. And he established this notion that he called trailblazing, where a reader would traverse across associated trails across information. He had this genius idea. It wasn't the internet. It was something called the Memex, which is basically where his vision was. It was kind of like an Evernote, but a 1940s version of Evernote, where someone would store their life's memories on microfilm, and then it was all in this big contraption that kind of looked like a banker's desk. Fast forward to 1960, when this associative trails sort of concept is expanded, when the Xanadu project is launched. It's the evolution of these sort of there's two things going on here. One is that Ted Nelson, the founder of Xanadu, introduces this great term called intertwingularity, which is essentially where he establishes that an associated property of knowledge is that its cross connections just can't be reduced to a hierarchical structure. And there's two interesting things that come out of this work. One is that he introduces the term hypertext. And he introduces the definition of hypertext as branching and responding text. I really want to focus on that term, branching and responding, because I'll come back to it later. He also talks about hypermedia, branching and responding media. So as we start to think about things like hyperdata and linked data, think of that term of branching and responding. It's kind of one of these core properties behind the foundation of the internet. He also associates hierarchical content specifically with Gutenberg and publishing in these early writings. He starts to establish that the Bush paradigm is different from the Gutenberg paradigm. This is in 1960. So there's 30 years of basically hypertext projects before Tim Berners-Lee comes along in 1989. And he does a very important thing. He abstracts the notion of hypertext from a specific piece of hardware like Bush or a specific piece of software like everybody in between, and establishes it as a communication protocol. So HTTP stands for Hypertext Transfer Protocol. So this basically establishes the World Wide Web, and there is now an explosion of World Wide Web servers, as we know. And this is an interesting thing happens here, which is that people are wild about this notion of connectivity, and the amounts of servers pop up all over. There's huge expansion of the internet, but they start to drift away from the spirit of the early hypertext systems at this point. So a perfect example of this would be in the first version of the browser, Mosaic. Mark Andreessen thought it would be natural for everyone to do annotation in the browser on all web content. They actually included an annotation feature in the original Mosaic, but at that time, the annotation server was so expensive, they couldn't figure out how it would scale. They removed the annotation feature from the web, where it's now only re-emerging as hypothesis and genius as this idea that the web would have open annotation. Yet another example of how the spirit of the web was kind of lost at this point. Okay, in 1995, the great sort of digitization wave begins. Specifically, Jstor is probably my favorite example, when journal publishers are pretty much asked by their customers, they're basically told by their customers that we don't want your product because we are tired of building new wings of our institution, and when you send us these paper journal stacks, also it's very difficult for people to access them on the institution. So essentially, journals become the first, one of the first true digital publishing efforts. It starts in the late 90s. By the end of the decade, 95% of the journal's revenues are coming electronically. It's solving the basic customer problems of storage and proximity to access. And it's only 3 years after Mosaic was launched, which is interesting to me. It starts getting very, very interesting, and this is where I want to focus, in about 2005, when the Linux project starts taking off as the world's first really huge open source software development. And as part of Linux, they solved this really large problem that's related to online distributed collaboration, which is version control. So Linux, the tools that came out of the Linux development, specifically Git, and the website that kind of contextualizes Git, which is GitHub, has this notion that if you want to work with someone and collaborate with someone and use their code, you can branch their code from the original code. If you want to do something fundamentally different, you can create a new fork of that code. And it all maintains a version, an audit trail back to the original code. The author of the code can accept your changes if they approve of them. And all of this is done without the good graces of a corresponding author. This is all online. It's built into sort of the way that internet collaboration happens. So GitHub now has 9 million users, and its fastest growing area is scientists. So this basically, this is a really interesting, this idea of branching and forking and version control is just basically a fundamentally important concept. This book comes out basically noticing this whole Linux development and saying, hey, wow, this is a wildly productive way of working. And by using open standards, where we essentially remove all the friction from people collaborating, there's this persistence. The content's always available online. It's easy to grab and fork and build on things. Nobody needs to own special tools or software to use it because it's all based on open standards. There's essentially zero friction in the system. This notion of Linus's law with Linus Torvalds, that with enough eyeballs on any problem, all bugs are shallow, becomes kind of one of the operating principles of the era. There's a great blurb on this book, which you can't see, but it's by Guy Kawasaki. And he essentially says that this is the most important book about technology today, and the implications go well beyond programming. So there's this sense in the air that it was changing the world. They didn't really even know how. There's just something fundamentally important about what was happening here with this open source software development. This ethos becomes Silicon Valley's main export. Tim O'Reilly specifically has built a whole brand around this idea of open source. You create more value than you capture. If you want to see 3 things that developers love and 3 things they hate, 3 things they love: Linux, Python, JavaScript. You will see stickers on the backs of laptops of these things all the time when you look at young scientists and young coders. You will never see a sticker of Flash, AppleScript, or anything from Microsoft. Interestingly, at this time, this is a bit of an aside, but O'Reilly also starts a GitHub-based authoring system called Atlas and Chimera. This is a bit under the radar. I got my first view of this in 2012, where it's essentially using GitHub to author book content. About a year later, Inkling, which was an ebook aggregator and had created these digital-first publishing system to create enhanced ebooks, pivoted their company and started selling these tools back to publishers. This is in 2012. So something's going on here. So essentially, we're exiting, I think, the first wave of digital publishing, which started with that Jstor era, 1995, and it's still today, but it's essentially where we put a digital lens over the print-based process. And we're about to go into this second wave of digital publishing, where we really use the affordances of the internet for what it's good for the problems of online distributed mass collaboration, which is essentially the problem of science. These people in the scientific community are influenced by this. They're the same people, the same researchers who are working in all kinds of scientific fields are the same people who are writing Python code, putting it on GitHub, forking and branching. They're the same people who are creating R code and R packages and doing the same thing. So this is their ethos. And open science, open source, same community. Okay, so in 2002, the actor Kiefer Sutherland went online for the first time in his life because he wanted to research an image for a tattoo that he was trying to get. And he did not have a good experience because at that time, the internet was, and still is, this was before the concept of rich snippets or machine-readable data that would be in common HTML. So in 2002, it's before we really started talking about things like JSON-LD, RDF, or schema.org. Google hasn't established schema.org. There's really not this idea of semantic web in 2002. In 2014, we basically have the same problem. So the New York Times reports a 50% increase in that innovation report that they published famously last year. They reported a 50% increase in their recipes because they started using rich snippets and semantic web content. So at this point, and this is a quote from a guy named Sebastian Ballesteros, who has started a new company called Science.ai. You will definitely hear his name much more in the future. But he says, at this point, cupcake recipes are reaping more benefit from modern data practices than the entire scientific endeavor. Which is a totally true story. Okay, so let's talk about why this is. How come scholarly articles are making their way online in less useful format than cupcake recipes? Well, the main thing is that we essentially, after years of consolidation in publishing, we've gotten very efficient, and this basically applies to all publishers at this point. We've gotten very efficient at manufacturing articles. We take the inputs from the author, we take their Word documents and their JPEGs, we increasingly send those offshore to article-making factories, which are usually in India for the large publishers. We have gotten very efficient and very good at this. We've consistently driven costs out of editorial, found a lot of scale here, and gotten very good at making these articles. Now the problem is that even though 95% of a journal's revenue is digital, we're still acting as if it's coming from print. We still think in terms of pages. We literally think in terms of pages. So we have page budgets, we have page charges, we price typesetter deals in pages, not complexity, not how hard it is to do a table, but in pages, even though these are being completely consumed online for the most part. We still think in terms of the linear article, and we think of data as something as supporting, as if it's not important enough to make the main paper and it was just kind of extra. That's why what we call supporting information. Essentially, our author value proposition is give us your Word doc and all your images. We'll make it really easy for you. We'll ship it off to our article factory. We'll make you an article. You can review what it would look like in print as if you were having a galley copy of your novel that you were publishing in this form of page proofs. By the way, this will take probably no less than 21 days. And then we'll give you back a couple of PDFs, one for your article. Oh, by the way, when you do your revisions, we just want you to type comments in the PDF. We'll send them back to the article factory, who will then convert them into the digital content like XML and HTML. Then we'll load that all up on the platform. That's basically our value proposition as publishers. And I think this applies to just about everybody, including the new OA native publishers, are pretty much on this kind of a workflow, to my knowledge. We push papers through editorial systems. That's what EEO stands for, where we've conflated content acquisition with facilitating peer review by basically pushing around Word documents and JPEGs. Then we mark them up in publisher-specific formats, XML, things like NISO JATS. Wiley has a proprietary one called Wiley ML3G, so that we can put this web, mostly this is metadata about layouts and publishing specific things, licensing information, things like that. There's not a lot of semantic, scientific information in that XML as a rule. We put it all up online where Google has no idea what any of that metadata means. Google does not speak NISO JATS, to my knowledge. They speak open web standards like schema.org and JSON-LD. We also, as our value proposition, we specialize in manufacturing, hosting, and moving around lots of files. That's basically what we do. As part of the way our systems are set up, the way our revision workflow happens, the way the typesetting process is inserted in there, the way we do online proofing, everything is basically based on files. Even the way the online platforms are supporting information are files, which are usually ignored because most people grab the PDF. So all that rich data is generally sitting there as inert files on a publisher platform. So what I want to talk about is what would happen if we made networked linked data our primary product? So that's the big change in the value proposition. So what if we transcended our role and we figured out how these new authoring behaviors like putting your code in GitHub and branching and forking it and having version control, or putting your data in a repository where it gets a DOI, can be linked to that paper, and we don't destroy all that interconnectivity in the publication process. In a lot of ways, we've been relying on text mining, which is essentially an industry that's sprouted up around smartening up articles that we have dumbed down in our own article factories. So what happens when we push that into the authoring phase and start embracing some of these open standards? So I think the next generation of, well, I don't think, this is already here. The next generation of publishing workflow will be HTML first. It's kind of an oversimplified way of talking about the workflow. But essentially what authors do, we have some work to do around standardizing the input formats. It turns out Microsoft Word docx is a pretty good place to actually create semantic content that turns into nice, tidy HTML if you use the right standards. So something's emerging calling docx standard scientific style, DS3, as a standard. Or we can have authors just submit directly into a new sort of wave of submission environment where they basically take their Word docs, it gets converted to HTML in the first step. They do a lot of work enriching things. Machine learning algorithms can help them tag things with ontologies. Individual societies and journals can start building out those open ontologies like schema.org in their area. So for instance, I was talking to Cochrane, who we publish for, who does systematic healthcare reviews. They've created this annotation taxonomy called PICO, Population Intervention Comparison Outcome. So we're trying to open up a new schema.org branch to make that into an open standard so that we can start tagging content with this open ontologies, and it can be turned into JSON LD tags when we publish them. There's no typesetting in this kind of a workflow. When you want a PDF, we create it on the fly using cascading style sheets. So CSS has evolved now to the point with a couple of techniques. I'm not an expert on this. CSS regions, I think, one Flexbox, a couple of CSS techniques. You can do cool multi-column layouts. You can still differentiate your journal with your PDF design, and you can do it all with style sheets. So documents are created when they're needed. But for the most part, the biggest implication of this is that when authors submit web content, then what we need is editorial and peer review workflows around that web content. And I think that, so what we're working on at Wiley is to try to do that based on annotation. So we've basically noticed that basically anything an editor does or a reviewer does can be described as a web annotation on web content. And we can create the architecture such that people can work with the native digital content, essentially annotating and improving it. So in this kind of a workflow, it's basically distributable online from the first minute the author submits it, but it's not ready yet because you haven't had all the other actors in the system improving that content. What you don't really need to do is break it into files and shoot them around to everybody. So I think there is a challenge on the, I don't mean to be singling out areas, but there's signs behind me. There is a challenge on the editorial systems to start embracing this kind of workflow because they still have a lot of great functionality for managing an editorial office. And we're going to try to work with them and their APIs so that we can work with this native content that we're working with authors to help convert. So this is really just a little bit more about data because we've talked a lot about this morning, but I really think if you think of data as a pipeline, so you've got the big data, the measured data that's coming off the instruments, the satellites, the sort of high throughput data, usually is getting, there's usually something a little closer to the paper that you might think of as the output data set or the analytic data. There's usually some statistical code that's run on that data that's increasingly in something like R. All of that is basically increasingly being stored on a place where it can live online. And then along comes the publication process, and we basically flatten that and break all those links. So I think that's what, the idea of just maintaining this pipeline. You'll notice that this trend of literal statistical programming has popped up. Because the journal supporting information system is so famously bad, a lot of people are solving it on their own. So you can go into R now and use something called the knitter package and essentially write your paper in R. Someone can basically install your paper and rerun your data analysis while they're reading your paper. That's what knitter is. Just a good example of how people will solve this problem on their own. There's many other examples I've heard of where people are essentially this is where I kind of want to talk about the difference between, is the paper getting diminished because the data, or is the paper expanding to become basically a linked data package that the user can essentially install and rerun the data? Those are open questions. Just a few things here, a little bit about the benefits of these digital first workflows. I think my talk was supposed to be about money. This is a unique opportunity for publishers to re-engineer their cost base while also kind of improving what they do. But it also allows us to put time and energy back into other parts that we've increasingly not been able to focus on, like data curation, helping authors navigate the maze of data repositories and data metadata tagging and things like that. Okay, so in conclusion, I think I do think science is going to kind of evolve into a new version of this Linus's law. This is basically saying that with enough eyeballs, as a kind of an organizing principle of science, if you remove friction from the system, you get enough eyeballs on the problem that all bugs are shallow, even scientific ones. And there will be a system of career recognition that evolves that more embraces the hacker ethic. And the hacker ethic is about a love of sharing. It's about anti-bureaucracy rebellion, but it's also a DIY ethos. This is kind of that O'Reilly maker culture. It's very influential, the way that the software open source world is bleeding into other parts of the world. And I think it's also one that doesn't exclude the opportunity for entrepreneurship and profit. This is increasingly what laptops of scientists are looking like. And I think the expectations for scientific collaboration will be on internet time. So we will gradually lose the ability to stay in the old publication kind of sense of schedule, issue-based. The idea that peer review is essentially a pretty leisurely process right now. The average publication time, I think, is about 120 days, and the long pole in the tent there is definitely wrangling reviewers. That's the one sort of most difficult time. But as the speed of this pace is up, the pace of this speeds up, there will be a lot less tolerance for that kind of thing. And then, I guess this is where I also make an argument that the journal, I think, stays relevant. And I think that's just because the powerful brands that were formed in journals are still meaningful. And I think that they still contextualize data with the power of argument. They still are the mechanism that prove to funders that what they fund is disseminated and impactful. There's still an excitement in getting published at the Lancet or at Angewandte Chemie. That's still an exciting thing. And I think, I think that, this web-based publishing, this linked data publishing, will tolerate different business models. It doesn't in itself, even though I think all the data will be open and all the standards will be increasingly open, it doesn't necessarily mean open access as what we think of as open access as a business model. I think it would support a mixed model world. Okay, that's my talk. Thank you very much.
Well, thanks very much, Todd. Well, we've done pretty well on time. Anybody got a question, Todd? Yeah, down here, Alicia.
Thanks. That was a cool talk.
Sorry.
I have a really detailed question.
Yeah.
And I'm not technical, so be gentle with me.
Okay.
But you mentioned EPUB 3 as a format for XML first and digital workflows, which is cool, because I think book publishers have embraced EPUB 3 and rallied around it in a way that no journal publisher that I know of has.
Yeah.
Any insight into why that is and how we can change that, or should we change that?
From what I understand from our standards person, the next generation of EPUB, the thing that replaces it, and I'm probably going to say the wrong thing here. I want to say it's something like HTML service worker, a couple other standards. But I think this idea of portable HTML is going to be the sort of PDF. That is the PDF successor. And when you have linked data, you have RDF packages, and you need to create something portable, I think it'll come out of that EPUB work, from what I understand. That's kind of the PDF replacement. Yeah. But I think that's pretty early. I think they're still working through standards on that, but that's the concept of it. Any other questions? Phil?
Hi, Todd. Thanks for that.
Hey.
I wanted to just kind of, this is kind of a small question, I suppose. You talked about the digital-first workflows, which I think is I think you're absolutely spot on with that. But you mentioned that docx is a great format for creating the, I suppose, the markup that eventually then turns into the XML and the HTML and the PDF and so forth.
Yeah.
But isn't that dependent, much like the linked data, on being on the researcher, on the author, structuring their documents correctly? Particularly in docx, most of certainly the biologists that I know that write in Word certainly don't use it properly in terms of like headings and things.
I think, and I'm working very closely with that firm I mentioned, Science.ai, in this particular area. So they're a startup that we're partnering with on that piece of it. So in terms of the way that we visualize the standards, you're right. They're docx or HTML. They're basically on a continuum of how semantically complete and well described they are, which can be expressed as a star system based on Tim Berners-Lee's definition of good web content. So if we can incentivize authors to spend the extra time to properly format things, create ontological tagging, and create a good piece of web content, and they could earn 5 stars of good web content, it doesn't mean you can't still submit a 1-star web content. So essentially, I think what we're trying to work on is how do you get that submission environment to help that author improve their manuscript. So can you use the machine learning at that point to say, hey, we think this article is about this. Are we right? And the author starts accepting tags, starts doing the classification, and basically raising their reproducibility score, if you want, for how good that piece of web content is. We also say, hey, this figure doesn't seem to be linked to anything. Is there any source data for this figure? Can you create the link now? Or will you upload the source data so we can look at it? So I think we'll be it'll almost be wizard-based as authors are working through the submission environment. All I meant about docx is that you can basically, my theory is that authors will cloud their data before they decide where to publish. And they will increasingly work on what we think of as content projects, not manuscripts. And that needs to be portable, because they need to move it to the next publisher if they get rejected, without recreating all the work. So you can't decide on a publisher, go in their fancy new editorial system, do all this work, and not be able to take it with you. The reason I brought up the docx standards, it actually is a pretty good portable standard for a good piece of semantic web content, which surprises people, because I think a lot of people think Word is the problem.
Shouldn't we be thinking about ways of making it more foolproof so that it's hard for researchers to mess it up?
Do I have to repeat that?
Yeah. Well, the other thing, we've also learned that you have a vendor convert to good docx from their, whatever the author's input is, substantially cheaper than having them convert to XML through a typical vendor workflow. So there may be someone in between helping the author get to that good input. Let's call that the input standard. There may be a future where you don't need a Word doc at all. Everybody uses online authoring. Everybody's working on something like Overleaf, Authoria. It's just creating good little RDFA bundles, and nobody uses Word docs. But we're a long way from that. For now, we have to think about how to standardize the input standards. Otherwise, it's hard to get off that typesetting-based workflow, I think. Yeah.
Hi,
Hi.
Carver from River Valley Technologies. I'm probably the only vendor here.
Oh, hi.
So, hi.
Hi.
Yeah, so we take those Word files and convert them to XML, convert them to PDF, as you say, put the annotations, send it back to authors, what have you, and it's completely nuts.
Yeah.
I agree with you. The process is mad. It's basically what we did 100 years ago, but we're doing it. We're sending attachments rather than sending, paper with a horse cart or post. So I've got a few points, but I'll try and keep them brief.
Okay.
I'm aware of what Science AI are doing, scholarly HTML. That's interesting. Going from XML to HTML, it is very attractive. If it's done absolutely right, it is good.
Yeah.
So it's fully structured. It's very dangerous. There are a lot of people saying, "Oh, we'll just go HTML first because it's easy."
Yeah.
You read it in the browser and it just works. So what I'd like to say is really good, but you've got to get it. Either it's absolutely right or it's a step backwards, because HTML is designed to be forgiving. Because everything should work in a browser. Browsers just forgive. So we don't want the scholarly publishing content to be on the same level as a cat falling off a sofa.
Yeah,
because it works.
I think that's a fair point. So just to be clear, scholarly HTML is the output standard, and I mean scholarly HTML. I'm talking about the evolution of what we now call HTML. As part of our production workflow, we're actually creating this is where my technical, but instead of our XML standard, we are creating a more broad standard, which we're calling Melville because we published Herman Melville, that incorporates other kinds of important publisher metadata. It's a more all-encompassing, basically, schema to store the content. So you're right. I'm oversimplifying it by saying we can do everything we do now with HTML first. That's a totally fair assessment. We will still continue to use vendors. We'll just use them in different ways. I think people logging in to look at rendered digital content and using annotation-based workflows is much better than creating a PDF, that kind of thing. So I think it's the same actors in the system doing different kinds of work that are more value added. But the most important thing to me is we don't break the linked data pipeline. We don't destroy value as part of the publishing process.
Thanks.
Okay.
Okay, Eleanor's asked me to finish this session now, so thanks Todd and thanks to all three speakers. Thank you very much.